Hello students, here are some of the molecular markers based on transposable elements. Transposable elements are jumping genes present in the genome. Within the classification of the transposable element, one of them is that retrotransposons, and it's having three categories, two of them having LTR flanks and one doesn't having any flanks of LTR. Here we are going to discuss about some of the main molecular markers based on the LTF flanks of the retrotransposons. They are SSAP, ERAP, REMAP, etc. First, we can go ahead with the SSAP. SSAP is a sequence-specific amplified polymorphism. Here, what we are going to do is that you have to get the DNA and you need to digest it with a restriction enzyme, and so you will get so many fragments of the genome, and then you have to add adapters and then ligate these adapters on both ends of the DNA fragments with the ligase enzyme, and then you have to carry out the PCR. In the PCR, here lies the key, because you have to carry out the PCR process with the forward and reverse primer. One primer that should recognize the retrotransposon region and another should recognize the restriction site or the adapter region. I will show you the pictures of it. So this is the picture. Here you can see this is a transposon, a retrotransposon that is inserted within the genome. So it's having a specific constitution because this is a transposon on both of its ends is flanked with LTR sequences, long terminal repeats. This is the long terminal repeat that is present in the one side of the retrotransposon. This is the retrotransposon, and this is another LTR that is present on the opposite end of the retrotransposon. So altogether, including this LTR, this main internal domain and this LTR, all of them together will become the retrotransposon. So in the PCR, what we are going to do is that you have to construct a set of primers. So one should bind or recognize this LTR with another primer that should be targeted against a restriction site adapter. This is one restriction site. This is another restriction site. So this will make one fragment of the DNA after restriction digestion. After that, you have to add adapters on both of its ends. See, this is an adapter and this is also an adapter. Here, one primer that is targeted against this adapter and another primer that is targeted against LTR sequence of the retrotransposon. That means if a retrotransposon inserted within the genome nearer to that of a restriction site, then only those regions will get amplified. PCR in normal ways it can amplify around 0.1 to 10 kb region of the DNA. But of course, long run PCR can amplify around 20 kb to 30 kb genome, but in normal ways this PCR can amplify only around a 0.1 to 10 kb size of DNA. So if this retrotransposon inserted adjacent to a restriction site, then only those regions will get amplified. Beyond 10 kb, then those regions won't contribute in the SSAP. So after the PCR process, you will get a pattern for one individual, and for the another individual, this pattern may be different. So it can be considered as a molecular marker. Next, we can go ahead to another marker, that is IRAP, IRAP. That means inter-retrotransposon amplified polymorphism. Here the basic principle is that if two retrotransposons those are present adjacent to each other, then the segment of the DNA or the segment of the genome adjacent to this retrotransposon will get amplified. For that, you need to design primers. Both primers should be against LTR of retrotransposons. That means one primer, you can see this is a primer. This primer should be against LTR of the one of the retrotransposon. This is the LTR of the one of the transposon. Okay, this is one of the transposon, and this is another retrotransposon. So this is the LTR of one of the retrotransposon, and this is the LTR of another retrotransposon. Okay, so this retrotransposon that lies adjacent to the another retrotransposon. This is the DNA in between these two retrotransposon. So here in this technique, you had considered two primers. One recognizes this LTR of the retrotransposon, and another, you can see it as a blue one. This recognizes another LTR of the retrotransposon. So region between these two retrotransposon or in between these two LTR region will get amplified. So this is the amplified product. This is the IRAP product. So if two retrotransposons, if they lies adjacent to each other, that means around 0.1 to 10 kb region, then only those region will get amplified, others won't. So within one genome itself, you will get so many IRAP products, and products contribute to the pattern of that particular individual. So this IRAP pattern may be different from that of the IRAP pattern of the another individual. So this IRAP can be considered as a molecular marker. Next, remap. Here in the case of remap, we are amplifying a DNA segment in between a retrotransposon and a microsatellite. That means if your retrotransposon is inserted adjacent to the microsatellite region, then only those regions will get amplified. So this is depicted in here in this picture. This is one retrotransposon having LTR flanks on both of its ends, and here you can see a satellite region or a microsatellite region. Designed one primer against this microsatellite region and another against LTR. So this region will get amplified. So this is the product of the PCR, and here also you can see a satellite region. If one of the primer that can recognize this LTR and another that recognizes the SSR region, so this region will get amplified. So here also you will get a product. So finally, a remap pattern that can be different from that of the remap pattern of the another individual.